this system is going to execute your payload. So in order to see what happens, I'm going to set up my reverse shell here. So I'm going to do nc mvop 4444, run it, and let's see if we get a shell, for what user we're going to get a shell, and what's going to happen. So proceed. Now I think that's going to run the payload. I think I have found the best tool for scanning your malware samples, which is 100% open source, and you must have it in your lab environment. This tool is called LitterBox. I found it on some Reddit forums, which I'm going to specify the link in the video description. And essentially this tool does scan your malware, performs memory scan based on specific rules using specific softwares, which I've explained a little bit later. Now, on a nutshell, this is just a web UI, so you can go there, upload your files, and they can be scanned with all the tools which are provided in this software. But not only that, the cool part is you can actually scan running processes, which mean that you can start your beacon, inject it into memory or into some kind of a process, and then run this tool against the process to check if something is going to be detected or not. I think that's super crazy, it's super nice, and I'm so hyped to show you that too, guys. It's so nice. So let me go over the documentation to explain what it is and how it works. So for example, we have PE analysis, but we can also analyze different kind of files such as office documents. We can analyze CSVs, XLS, doc files, and so on, which I didn't play much up to that point. I just played with exes and DLLs, but pretty much that's all you need, right? If you do malware, it's going to be either in a DLL, either in an exe, or either in any of these kind of format. I know that there's always going to be some of you guys who is going to create some kind of a shady way of triggering malware, but you know, the main idea here is to check your beacon, how evasive it is, and if you can evade some of the defensive mechanism which this tool applies. Now, on the top of the head, this tool performs two types of analysis. On the one hand side, we have static analysis engine, which is going to do first a signature-based detection, which most of the AVs and EDRs are doing even before you execute anything. Then we're gonna go over binary entropy analysis, which is super important, guys. And one of the best reasons why that's a big deal is this teaches you to not embed your shellcode inside your binary itself. For example, if you write C code and then in that C code you define an array and then place your shellcode there, this is gonna increase the entropy of the file so much that just based on that, it can be detected, especially if the shellcode is encrypted. So one of the best ways you can do to avoid such kind of entropy detection is to pretty much stage your shellcode either from web, from SMB, from different files or different services, so it's not on your binary, which is actually analyzed and scanned. Then we also have string extraction. So if we have some kind of a malicious string inside a binary, this static analysis is actually possible of retrieving the strings and alerting that they're kind of dangerous ones. And of course, we have pattern matching for suspicious indicators. Now, what that means, I pretty much don't know, but we're gonna try to figure out when we run the tool. Now, on the next hand side, we have dynamic analysis engine. And now here is where it gets interesting. So as mentioned before, we have two modes of working. You can either report your file, or you can pretty much start your beacon and then scan the running process on your system, which is super crazy. Now inside the dynamic analysis phase, we have a lot of the things, and it's kind of a big deal. First, we have behavior monitoring. We have memory region inspections. So for example, if you have, let's say, the combination of virtual alloc, write process memory, and then create a remote threat, this is going to be for sure be flagged there. And also it's going to scan the memory for specific regions, like regions who have read, write, execute permissions, which is going to pretty much mean that we can execute, write, and read from the memory, which is by definition malicious. Then we have process holding detection, we have injection technique analysis, sleep pattern monitoring, which is one of the best things for why I'm trying this tool. For example, this tool tries to hunt and see if any process is an active beacon in sleep mode and so on. Then we can, it also can collect ETW providers, so it can extract a lot of the details from various processes and services and pretty much report them back. And also we have PE integrity verification. Now, to do all this stuff, the LitterBox is actually a combination of several super important tools. So for the static analysis phase, we have mainly Yara and Check PLZ, which is AV detection testing, and I think that's for the signature-based detection and so on. So that's some project we can maybe dig more in future videos, but for now let's just leave it be. But for the dynamic analysis part, we again have Yara, we have Preceive, we have Moneta, Patriot, RedTDR, and Hunt sleeping beacons. Now, as mentioned, all these tools are combined together, so as soon as you upload a file or scan process, they're gonna give you a lot nice and good results of what is actually detected from this malware. And trust me, EDRs rely a lot on tools just like that, on ETW providers, on memory scanners, and so on. So if you make a malware who evades all this stuff and LitterBox says it's clean, then most likely you're gonna have a high chance of evading EDRs. Now let's continue. One more nice advantage of the tool is that you have a web UI. You can create your web UI, everyone can connect, upload files and analyze them. Not only that, after you execute something, you can then from the web UI choose what PID to scan. And not only that, but also as mentioned in their documentation right there, we have an API. We can, guys, that's crazy. We can automate the whole process. We can automate that. We can directly upload file by doing a post request to upload. We can get all the files. We can see what was analyzed because there is a history for that. We can see based on the file hash, we can see the results of a specific file if of course it was not deleted. So I didn't use the API so far, but it's crazy that we have such integration for such kind of a tool. Now let's get back to the installation process itself. The whole thing runs Python and it uses Python to wrap all the functionality around. So we're gonna need Python 3.11 or of course higher. We're gonna of course need administrator privileges and of course you're gonna need Windows, because this tool is designed to be executed on Windows and not on some Linux distributions and so on, because you know we need to analyze the malware on our system, how it's gonna behave. So in order for that to happen, all you can do is do Python download, just type it like that, go to the first link and just download the latest version of Python. Right now I'm using Python 3.13.1 and the tool is working completely fine. I'm not sure how this can behave using different kind of versions, but of course you can always test, give feedback, so we can, if you find any bugs, we can write to the creators of the tool and they probably hopefully can fix them. But for now, as mentioned, I'm using this exact version, and for me in my testing before the video shoot, it worked pretty nice. Now, the setup steps are extremely simple. All you have to do is follow the documentation and literally copy and paste all this command. For example, I have Git on my Windows, so I just copy and paste the command. The first one is going to download the repository to your local system. The second one is going to actually install all the needed dependency. And the third one is actually going to start the tool itself. Now, by default, you're going to have your interface to run on that specific endpoint. So it's going to be on local IP address, loopback address, port 1337, but this can be configured inside the config.yaml. This file not only configures the endpoint to listen on, but also on what directory to upload the file, so you can pretty much exclude that from the AV and so on. We have some options for the analysis toolpaths, for the rules location, and for some timeouts. So the config file is definitely something worth taking a look for, but for honest, I don't think it's necessary. And of course the UI looks like that. It's super clean, it's super nice, so let's get it to work. As mentioned before, I just ran this command before, but trust me, it's no different, just literally copy and paste them and you should be completely fine. And when that happens, if I open my PowerShell screen as administrator, cd into home, cd into desktop, LitterBox, and now I can do Python, see my Python version. Nice, I didn't know that and why that worked, but now if I do Python litterbox.py, as mentioned, it's gonna start the endpoint on that specific URL. I'm just gonna copy and paste it to my browser, and pretty much that's it. I'm pausing the video just to say massive thanks to my Patreon sponsors. You mean the world for me, guys. if you also have appreciation to my work, don't hesitate to become a patron, and based on your tier, you're gonna get added to my GitHub organization. There you can see pentesting know-how, you're gonna get access to Shadowbot, my private packer, 7-3 evading EDRs, and also my Houndstooth agent based on PowerShell. So have fun, and thank you for your support. From the first look of the two, I must admit that it looks super good. I mean, for a tool which is supposed to be back-end and specifically designed for its functionality, I have to admit that this tool looks extremely good. So we have a nice top bar, which is gonna actually says our operation. We also have the status active, which is gonna report if there's some kind of a problems. And we have a main page, which we can pretty much upload file, or we can use the menu to pretty much clean any previous results, to see any previous results, to analyze a running process, which is extremely nice. And here we have to analyze option to analyze the payload. Now, let me generate one MSF Venom binary. We're gonna upload it here, and we can see what happens. Now, one thing I found to be minus or disadvantage to this tool is that it supports a maximum file size of 16 megabytes. Now, don't get me wrong, all of the beacons are inside that 16 megabytes range, but if you generate a payload such as the one from Athena, from Mythic C2, it is like 60 megabytes, which is a lot more than that. And that gives me the question, well, why don't I use bigger payloads inside my operations? They are less likely to be scanned and detected. But that's a point for another video. Now I'm gonna go back to my Kali VM. From there, I'm just gonna type my password super fast. Then I'm gonna open a new console. And actually, I'm gonna go to desktop, zoom in a little bit, and now do MSF Venom, Windows, x64, shell, reverse, TCP. So if we didn't do that, we're now generating a stageless payload. If we were to do that with a slash, then it's staged. But I want a stageless payload because the whole payload is gonna be inside the binary itself. So we're gonna see the entropy and not only that. So here I'm gonna set up the L host to be ETH0, then I'm gonna set up the upload to be 443, or actually let's do it 4444. And then the format is going to be exe, output is going to be shell.exe. Now, while that is generated, one thing I forgot to mention is that you need to disable your AV or make an exclusion for the folder the malware is going to be uploaded. Why? Because if the AV detects and removes the file, the tool is going to have a hard time scanning it, so that's not the idea. The idea is to have a designated window, which is just scanning your malware and seeing its weak points. So you don't need an antivirus there, you need to run this tool. Now the show.txt is generated, so what I'm gonna do is run my Python 3 to download it. I know I can use the API, but I don't feel like doing it now, so I'm gonna do 172.60.60, navigate to my IP address in the Kali machine, then download shell.exe. Okay, now it is downloaded, so I can open inside that folder and pretty much upload it. I'm gonna go to LitterBox, I'm gonna click here and just specify shell.exe. Now, of course, the name is obviously something malicious, but now let's see the output and what this tool actually found. So on the first page, we have static analysis. So if I click here, we are running the static analysis and we have a summary. Now in that summary, we have the targeted file. So it used some kind of it also copied the file I provided into its own folder. So in theory, if you go to desktop, LitterBox, and then upload, you're gonna find the file there, including its file hash. Now with that, it found threats, and that's just for static analysis part. And both Yara and check PLZ found that this is suspicious. Now in the Yara, 3 rules matches were found, and we're gonna see which rules from here, I believe. And on the check PLZ, it found Trojan Win64 Interpreter, so that was the signature it triggered. Now if we go to Yara, I think we can find the exact rules which were detected. So for example, here we have Trojan, Metasploit, and some ID. We have threat, Trojan, Windows, Metasploit, and we have the root file, which is scanners, Yara rules, Windows, Trojan, Metasploit.yar. So this is the rule. By analyzing the rule, we can see what the rule is doing and what was detected. We have also string matches, so most likely this was the string which actually was detected from the rule, but I am not completely sure on that. Having the similar results, we have 3 rules detected, and pretty much that's for the Yara itself. Now if we go to check POZ, we have threat detection details, we have the detection offset, we have these bytes, so the 201st byte was detected, as far as I see. And here we have showing 128 bytes around the detection point. So that's nice because it can allow you to pretty much see on the byte level which was detected, so you can pretty much try to obfuscate a string, evade it in some form, and so on, and you know on where exactly these two managed to detect your malware, which I think it's so nice. Now let's go to the dynamic analysis and see what happens there. So about to execute the payload, are you sure you want to proceed? So yes, this system is going to execute your payload. So in order to see what happens, I'm going to set up my reverse shell here. So I'm going to do nc mvop 4444, run it, and let's see if we get a shell, or what user we're going to get a shell, and what's going to happen. So proceed. Now I think that's going to run the payload. If we go back, we should see in theory some connection. In theory, I think the IP address is the same. So ETH0 is indeed that IP. And yeah, we have some kind of a shell going on. I was too slow to do a whole command to see from who it originated, but we're gonna do the test one more time and we're gonna try to be fast in the next one. Now the dynamic analysis is completed. So it executes the malware, try to see what it does, and then immediately shut it down in order to maybe avoid damage, but I'm not sure. Then on the analysis part, we have all of the things which was detected. Now, Moneta, Patriot, and Hunt Sleeping Beacon all resulted into clean result, which I'm not sure why they did so. But Yara again and PCF detected that something was not alright. And here we have all of the different, let's say, tools that was executed designated by specific options. So if you go to the Java, I think we have the same exact rules. So on the when the binary was executed, again it was used Java to scan it and the exact rules were triggered, so nothing fancy and new there. Then on the PC part, here we have status suspicious, so it was essentially detected to be an implant. So we have suspicious implant, implanted SHC, which I'm not sure what it means, but here we have the raw analysis output, we have the PID, we have what it scans for, we have scanning for EIT hooks, scanning for threads, alright, then some modules, and we have the report. Now we have total scanned, and yeah, pretty much, I didn't work that much with PC before, but essentially, maybe it scans for, based on the output I see, it scans for different kind of thing. For example, if we have hooked some kind of a DLL, if we replace some kind of a DLL, if we hook the IIT, and so on, and essentially it is reported to be an implant, which I think is the case. So I think it works pretty nice so far. Now, as mentioned, Moneta look clean, I don't know why. Patriot also look clean, I don't know why. Sleeping beacons also look clean, I don't know why. And here we have no data available. So these two, I don't know why, but this part, the TDR, I'm not sure why it's not working. Maybe TW is not enabled and some providers are not enabled on my system, but this is something I am yet to check. Now what I want to do is to run this analysis again and try to be fast into actually typing the my command and see from which user actually this comes from. So let's see if I'm fast enough. And if I do who am I, we can see it's from my current user, so it's not doing some kind of its own dedicated user to make into sandbox environment, but I think it works quite nice. Now I want to see what's gonna happen if you pretty much scan a process. So what I'm gonna do is I'm gonna set up my listener one more time. I'm gonna go to Quant01. I'm gonna start another PowerShell as an admin. I'm gonna see the home, see desktop maybe, no, cd downloads, and from there I'm gonna run shell.exe. So I'm gonna first make sure that I have a beacon to it and everything's alright and I can communicate with it. And next, what I'm gonna do is I'm gonna open my task manager. I'm gonna go to details and then do shell.exe, see the PID which is 6020. And now the best part about this tool, in my opinion, is that you can analyze running process. So it's gonna perform dynamic analysis on the running process. Yes, thank you for the warning. Doing 6020, starting the analysis, and let's see what's gonna happen. Now again, expectedly, we have the similar results, but here the main thing is that you can run your beacon. You can maybe pack it, try to make it as much obfuscated as possible. You can start it on a designated system and then scan the process and if your injection is stealth or not. Now, this tool to me is a must to have in your lab because it allows you to not only scan your files, but detect what the different tools which are used a lot can see. For example, YARA rules are 100% implemented inside each and every EDR, or maybe AV themselves. eSIF, Moneta, these are all memory scanners which I think are integrated into EDRs, and if not, EDRs are having their own alternative, but still the aim is the same, to make a memory scan and see if specific malware is detected or not. So having this tool in mind and having this tool in your pocket can be dynamically increase of your evasiveness, because as soon as you generate a beacon, as soon as you pack it, you can send it here and see what was detected at what point, and then you can go to the source code, try to modify it, test again, and if everything looks clean here, then you're gonna be more confident, and then you can for freely put it and test it in real environments such as an EDR and so on. So if you are looking for some open source tool that is helping you build better payloads, I can 100% recommend you guys this specific one. That was the video. Thank you so much for watching. If you appreciated the content, make sure to smash that like button and also subscribe to the channel. This helps me a lot. I'm gonna see you in the next one. Hope this was useful and wish you a nice day.